Welcome to AI Frontiers. Today's episode, Universal AI, Machine Learning at the Frontier, explores the latest advances in machine learning as revealed by 40 recent papers in the cs.LG category. This episode highlights breakthroughs in multimodal models, data-centric AI, robustness, and more, with a special focus on Dong Sixun et al.'s standout research. Discover how these innovations are impacting fields from chemistry to healthcare and language, and join us at the cutting edge of AI research. Did you know that a single artificial intelligence model can now predict the properties of molecules, materials, and catalysts in just minutes? Tasks that previously took weeks of simulation? Universal AI models, now adopted in labs worldwide, are accelerating drug discovery and the development of sustainable materials. These multimodal models can simultaneously see and speak, eliminating the need for domain-specific tuning. The ripple effects of these breakthroughs extend into everyday life, from personalized movie recommendations to environmental anomaly detection. With AI learning ever more like humans, the question arises, what further possibilities lie ahead when machines acquire such versatile skills? Machine learning forms the engine behind much of today's modern technology. Rather than simply following pre-programmed rules, machine learning enables computers to recognize patterns in data and adapt accordingly. This foundational approach powers systems such as voice assistants, self-driving cars, and advanced medical diagnostics. The research discussed today bridges the gap between theoretical developments and real-world applications, guiding our exploration from core ideas to their broader societal impact. Understanding this field is essential to appreciating how AI continues to grow in versatility and influence. To visualize the field of machine learning, imagine a bustling city where each research paper is a building and each major theme is a busy avenue. Foundational theories stand as towering skyscrapers, while practical applications resemble lively cafes where people gather and benefit from new ideas. This city is constantly expanding, interconnected, and perpetually under construction. Machine learning serves as a dynamic library, bringing users the information or solutions they need, tailored to their preferences. At its core, the technical concept of learning from data allows AI systems to adapt and improve, rather than simply execute fixed instructions. The first major theme in today's research is multimodal and cross-modal learning, which focuses on enabling AI systems to process and integrate different types of data simultaneously. For example, Dong Sixun and colleagues propose a model that aligns visual and textual representations of time series data, enhancing forecasting capabilities. DisasterNet LLM combines images and textual information to classify disasters more effectively, potentially speeding up emergency response. The metaphor often used here is that of giving AI both eyes and a voice, allowing systems to comprehend and interpret information in a more human-like way. Technically, this involves contrastive learning, which aligns varied data types within a shared semantic framework. The second prominent theme centers on data-centric machine learning, emphasizing the critical role of data quality and distribution over mere volume. Yuqing Wang and collaborators demonstrate that selecting training samples which are evenly distributed accelerates learning and enhances model accuracy. Paul Wachter and his team show that blending real and synthetic data provides greater flexibility and robustness across domains. The prevailing metaphor likens this process to a chef whose dish depends on the quality of ingredients rather than quantity alone. Effective data selection strategies are thus key to reshaping AI's overall effectiveness. The third key avenue is robustness, safety, and calibration in AI systems. As machine learning models are deployed in sensitive and high-stakes environments, such as medical diagnosis or autonomous vehicles, it is essential to ensure their reliability and predictability. Zain-ul Abidine and collaborators present scalable methods to enhance model robustness even when encountering unexpected data. Xiaoyang Li's research focuses on calibrating the confidence of graph neural networks, thus improving the trustworthiness of their predictions. These measures can be compared to the brakes and seatbelts in a self-driving car, providing critical safeguards as AI becomes more deeply integrated into society. Across these research fronts, several key studies exemplify significant progress in the field. Dong Sixun's group demonstrates how aligning visual and textual signals enhances the accuracy of time series forecasting. Yuqing Wang's work on uniform data selection reveals that even data distribution can substantially speed up learning. Brandon M. Wood and the MetaFair team introduce UMAT, a universal model for atomic structures that achieves top performance in chemistry and material science tasks without requiring fine-tuning. Jen Li and colleagues accelerate diffusion models via training-free algorithms, making generative modeling more efficient. Each of these studies represents a step toward more effective and insightful AI systems. Turning to the featured research, Dong Sixun and colleagues present the paper Teaching Time Series to See and Speak. This study addresses time series forecasting, a task fundamental to domains such as finance, healthcare, and environmental monitoring. Traditional models typically process only raw numerical data, offering limited interpretability. The central question is posed: what if artificial intelligence could both visualize and describe complex data? Much like a skilled human expert, the primary innovation lies in aligning visual and textual representations to yield richer, more actionable insights from time series data. Delving into the technical aspects, Dong Sixun et al.'s model transforms raw time series data into both image-like and text-based sequences. Contrastive learning is employed to semantically align these distinct representations, creating a unified understanding of the underlying data. An additional variate selection module highlights the most important variables within complex multivariate datasets. The approach is validated on 21 diverse forecasting datasets, attesting to its broad applicability. Notably, the model consistently outperforms single-modality baselines, particularly in tasks demanding high-level semantic comprehension. The significance of this research extends beyond technical innovation. The work draws inspiration from how humans interpret and explain complex data by integrating multiple perspectives. This methodology enables AI to operate in domains where traditional language or imagery is unavailable. The public release of the codebase invites collaboration and further development by the research community. By bridging human expertise with advanced machine learning, this work sets new standards for interpretability and accessibility in AI-driven forecasting. Looking ahead, the trajectory of machine learning research can be likened to a river, drawing in new tributaries such as richer data streams and more robust safety mechanisms. Principles for data-centric and multimodal AI are expected to gain increasing prominence. Foundation models like UMA may revolutionize scientific discovery by enabling cross-domain applications without the need for extensive domain-specific tuning. Human-in-the-loop systems, enhanced interpretability, and a focus on societal responsibility are anticipated to play pivotal roles. This hopeful analogy envisions AI as a nourishing force, expanding its positive impact across new fields. In conclusion, the ongoing evolution of artificial intelligence is not solely characterized by algorithmic advances, but also by a growing awareness of context and real-world impact. Research by Dong Sixun et al. And others demonstrates that AI can learn and interpret in increasingly human-like ways. Ensuring responsible, transparent, and rigorous research practices remains essential. Listeners are encouraged to explore the referenced papers. which are included in the episode notes, and to consider their own perspectives on the future of machine learning. Engagement and inquiry are key to staying at the forefront of this dynamic field. The synthesis presented in this episode was generated by GPT 4.1 from OpenAI, drawing from summaries of 40 recent research papers. Text-to-speech narration is provided via OpenAI's TTS system, with visuals described for accessibility. Image prompts were created using Grok for illustrative support. Content was reviewed by human experts. However, minor oversights may persist. All references are provided for transparency and further exploration. Thank you for joining us on AI Frontiers. Subscribe for more deep dives into AI research breakthroughs and stay updated on the latest developments in machine learning and its practical impact. Follow the AI Frontiers channel and share your questions and discoveries with our growing community. Let's continue to explore the future of AI together. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer, this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.